In this video, I will show you how to use the properties of logarithms to expand or condense logarithmic expressions. These are the 4 rules regarding logarithms that you guys are supposed to have memorized, all right? Probably at this moment you don't have them memorized. You need to memorize them over the next couple days, especially the kids that are going into calculus next year, all right? These rules will come back in various ways throughout the calculus course. So commit these to memory. You've got your product rule, which says that if you have the log of something times something, it can be expanded as the log plus a log. Quotient rule, if you have the log of something divided by something, you can rewrite it as the difference of 2 logs. You have the power rule that says if you have the log of something that has an exponent, you're allowed to put that exponent in the front. And then there's the change of base formula that we already talked about yesterday. Everything on the left side of the rule is considered condensed form. Everything on the right side of the rule is considered expanded form. And we need to be able to go back and forth between condensed form and expanded form. So that's what we're going to practice today. So looking at problem number 1. Problem number 1 is really a combination of the product rule and the quotient rule. Because in the numerator, we have a product, right? We have 4 times x to the 5th power. But then, of course, all of that is being divided by 11. So when we talk about the product rule, we write something plus something. When we do the quotient rule, we do something minus something. So how do we handle it when we have a product and a quotient all mixed together? Well, we have 3 factors. So we're going to expand and have 3 terms. The bottom line is every term that comes from the numerator is going to be positive. Every term that comes from the denominator is going to be negative. So I'm going to do log base 3 of 4. That's positive because it came from the numerator. And then I will have plus log base 3 of x to the 5th power. That's positive because it came from the numerator. But then I will have minus log base 3 of 11. That last term was negative because it came from the denominator. That's your quotient rule sneaking in here. Okay? So we've expanded. But after you do that step, you should look at each term and ask yourself, is there a power rule that we could yet do? Do you know which term I'm looking at right now? Yeah, that one in the middle. We have that x to the 5th power. The power rule says that if you have the log of something with an exponent, you're allowed to take that exponent and put it out into the front. Okay, like you see this n out in the front. So looking at this middle term, we are allowed to take this exponent of 5 and put it out in front. And for expanded form, that's what we have to do. So this is going to be the same thing as log base 3 of 4 plus 5 log base 3 of x minus log base 3 of 11. So that would be the final answer for number 1. For problem number 2, Will, what's another way I could write the square root of x? To the, not squared, that's close. Still close, but not quite. Duncan, help him out. What's another way? X to the 1/2 power, okay? So square root is the same as 1/2 power. I had to write it that way because now it's clear that I have an exponent. So I should be able to use the power rule. Okay, so Carson, what's another way I could write this expression using the power rule? We could just write 1/2 log x. Okay, that exponent can come in the front. So that's it for problem number 2. Wasn't very much to it. Okay, so when you look at number 3, look at this as a product. So according to the product rule, we can write this as a log plus another log. So we can rewrite this as log base 8 of 64 plus log base 8 of x squared. Siona, that first expression, log base 8 of 64, that's something we should be able to just simplify kind of in our heads. Do you know what I'm talking about? Do you know what the log base 8 of 64 is? 2, right? Because yesterday we learned that a log is just the exponent that turns that base into the other number. 8 squared is 64, so this is going to just be a 2. Okay? Grace, what can I do with this log base 8 of x squared? To log base 8 of x. Correct. All right, Natalie, looking at problem number 4, okay, can you give me the first step for expanding this? How many terms do you think we're going to have when we expand this out?
4.
We're going to have 4 terms. All right, can you go ahead and just say the terms for me? So we'll have natural log 5.
X.
Okay. Oh yeah, should these be positive or negative, these first 2 terms?
Positive.
These are going to be positive. How did you know they were going to be positive? Because they're on the top. So we have natural log 5 plus natural log x. What's the next term going to be?
Minus 2.
Let's go ahead and say the natural log part.
Natural log y squared.
Keep going.
Minus natural log.
Okay, so that's the first step on that problem. Again, notice the first 2 terms are positive because those came from the numerator. The second 2 terms are negative because they came from the denominator. Is there any power rule that we can do to finish this problem off?
Yes, the y squared. The 2 in front.
The y squared, we can put the 2 in the front. So this would be the final answer for number 4. For the next few problems, we need to go in the opposite direction. So these terms are expanded. We need to now combine them into a single log. But first, we need to get ready with the power rule. So when you see this 5 in the front of this term, what can I do with it instead? You can just blurt out this answer if you can. You can make it as the exponent. And same thing with this 4. So your first step will be to write log base 4 of x minus log base 4 of y to the 5th power. Sure, sweetie, you can skip to the answer if you want. All right, so Sophia, what's going to be in the top? X times z to the 4th power. We knew those would be in the top because those come from the 2 positive terms. And of course, what's going to be in the bottom? And then in the bottom, we'll have that y to the 5th. We knew that would be in the bottom because that particular term was negative. Okay, Francesca, looking at number 6, tell me, what did you do first? That's right, we can move those 4s over as exponents. So this would be log base 16 of 12 to the 4th power minus log base 16 of 2 to the 4th power. So now what are we going to do? Correct. Now there's one additional step we can do, and this is just a property of exponents. It really has nothing to do with logarithms. Notice that the 12 and the 2 both have the same power. All right, is everybody paying attention? Because this is like slightly new. When both numbers have the same exponent, that would be the same as writing 12 over 2 to the fourth power. All right? Because when you apply a power to a fraction, you just put that power on both. So if you see two numbers that have the same power, you can sort of reverse that process. I did that because in this form, you can easily see what am I going to do instead of writing 12 over 2 back to Francesca. What am I going to put instead? I'm just going to put a 6. So that's a little bit more simplified. So we would write log base 16 of 6 to the fourth power. Kabam. All right, Duncan, what is your thought process for number 7?
We're going to need to move the variables in the front to the exponents.
Okay, it sounds good. So tell me what to write.
Natural log x to the a minus natural log y to the b minus natural log z to the c.
Sounds good. All right, brother, it's time to rewrite this as a single log. What do you got for me?
Natural log x to the a over y to the b times z to the c.
Correct. And again, he knew that the x to the a would be in the numerator because that was the positive term. The other two came from negative terms. That's how he knew to put those in the denominator. All right, there's a couple different ways to do number 8. Daniel, what's your thought process on number 8?
Move the 2 to the exponent on number 8 on 8 and then put log 13 on the numerator and log 8 squared on the denominator.
Okay, that works. Notice that Daniel is moving the 2 and he's leaving the negative sign there. That's fine. Okay, this is one correct way to do it. So in this way, the first term is negative. So that's why Daniel said to put that on the denominator. So when we write our single log, it would be log 13 over 8 squared. So that's one way to do it. Can anyone think of another way to approach this problem?
Sure, I can.
All right, Nathan, talk to me, brother. why are we laughing? Hold on. All right, what's your thought process, Nathan?
So when I bring the -2 to an exponent of the 8, I switch it to 1 over 8 squared.
Okay, so the key step that Nathan is doing different is he's taking the negative with the 2 instead of moving the 2 without the negative. That is equally valid. So this will give us log of 8 to the -2 power plus log 13. In this form, both terms are positive. So we don't automatically drop anything down to the denominator, except for the fact that, like Nathan said, if you have 8 to the -2 power, that's the same thing as 1 over 8 squared, all right? That's just what a negative exponent means. But now, because both of these terms are positive, we wind up just multiplying 1 over 8 squared times 13. But when you do that, you get the log of 13 over 8 squared. 13 times 1 over 8 squared is 13 over 8 squared. Kabam! All right, these last few problems are like playing a little game. We're given that log base 4 of 6 is equal to P. Log base 4 of 9 is going to be represented by Q. And log base 4 of 7 is represented by R. So we need to take each of these expressions and rewrite them in terms of P, Q, and R. Notice that all of these expressions have log base 4 in them. So just focus on, we have a 6 and a 9 and a 7. So basically when we rewrite these expressions, we need to try to rewrite them using only a 6, a 9, and a 7 wherever possible. So does anyone have any ideas on the first one, how I could turn this into a 6? Sophia, real loud from the back. 6 squared. That's how we can get the 6 involved in this. So if I rewrite this as log base 4 of 6 squared. So now, what can I do with that 2? So now I could put the 2 out to the front. So now I have 2 times the log base 4 of 6. But remember, the log base 4 of 6, that is p. So I can replace the log base 4 of 6 with the letter p. So the final answer here would be 2p. On part B, we have log base 4 of 1/9. 9 is one of the numbers that I want. Does anyone have a guess as to how I will rewrite the 1/9? I see Sophia's hand, but I want to get more people involved if I can. Naya? 9 to the negative first power. Can you guys see how that would be the same thing? So if I write log base 4 of 9 to the negative 1 power. And of course, Naya, what am I going to do with that negative 1? So now I can bring that to the front. So I have negative log base 4 of 9. And again, the log base 4 of 9, we are told that is q. So I can replace the log base 4 of 9 with the letter q, and that just gives us negative q instead. All right. Is there anyone I haven't called on yet? When you look at 63 and we're trying to get a 6, a 9, or 7, what pops into your head? Anybody I haven't called on yet that has an idea? All right, back to Sophia, I guess. All right. 63, what jumps into your head? 63 is 9 times 7. So that's how I can get these two numbers involved. Got to know your multiplication facts, but this is honors pre-calculus, so I'm betting most of you know your multiplication facts. Can't say everyone, but most. So we can rewrite this as log base 4 of 9 times 7. And then what can I do with that? I can do that product rule. So tell me exactly what to write. Correct. Both of these things are things that we have been given as letters. So what will you put for your final answer? So this is just Q plus R. Kabam. So this last one is a little bit tricky. We have a 3 and a 32, and we're trying to get a 6, a 9, or a 7. So it's not immediately obvious what to do, but looking at the 3 and asking ourselves, how can I turn that into a 6, a 9, or 7? We could either square the 3, and that would make a 9, or we could multiply by 2, and that would make a 6. I'm going to go with this option because this is something that I can do without changing the value of the fraction, as long as I do it to the top and the bottom. So if I multiply by 2 over 2, then on the next step, I will have log base 4 of 6 over 64. So now, using our properties, using the quotient rule, I could rewrite this as log base 4 of 6 minus log base 4 of 64. Log base 4 of 6, that is p. So I'm already good on that one. So this is already just going to be p. Whoops. P minus. Log base 4 of 64, we should be able to evaluate that in our heads and just say an answer. Just blurt out the number. What is the log base 4 of 64? It's just plain 3. Because the log is the exponent that turns turns the base into the other number. And 4 to the third power is 64. Okay? So this is just plain a 3. Kabam!